Hello, welcome to the second day of 7.1. Today we're going to take a look at circumference and arc length. Now if we look at this number, 3.14159.265, so on and so on. I think this is the first 1,000 digits or so of pi. This represents pi. It's pretty amazing. It's a number that keeps producing more and more decimals. However, those decimals never terminate, so that it never ends, and there's also no pattern in these numbers, which has mystified mathematicians for thousands of years. Now, we get this number if we have a circle. If I took the distance around the circle and divided it by our diameter, we will always get the value pi. If we measured correctly, I should say, we should get pi. Now, if I want to find the equation for circumference, I just have to multiply the diameter on both sides. So it's just circumference equals diameter pi. So that's our first equation in your notes. If c is the circumference and d is the diameter, it's just circumference equals diameter times pi. But since we know that diameter is twice the radius, we could also write the circumference as 2 pi r. Or some people would write 2r pi. Both of them work just fine. So if we want to find some circumferences, this first one, our radius is 7. So our diameter is going to be 14. So our circumference is going to be 14 pi centimeters. Nice and easy. This one's even easier. We're given a diameter, so our circumference is 12 times pi centimeters. So now this one says let's round our answer to 2 decimals. So they don't want our answer given in pi. So if my radius is 9, our diameter is going to be 18, so we could say our circumference is 18 pi. So if I want to find out what that value equals, I'll take out my trusty calculator and I'll do 18 times pi, which is this, or I could have just done 18 times 3.14, which is an approximation for pi. Notice how the numbers are slightly off. This is 56.55, this is 56.52, but they're close enough, and when you're doing a test or anything, we'll take account what your answer is. So the best answer, the most accurate, is the 56.55. Now let's talk about what this means. That means if I have a circle where my radius is 9 centimeters, the distance all the way around the circle here is 56.55 centimeters. Now keep in mind, on this previous problem, when we said the circumference is 12 pi, that doesn't mean this outside is 12. It's 12 times pi. It's a common mistake that people make. So if I really wanted to find out the distance around this, I just take 12 times pi, 37.7-ish. So the distance around this circle is actually 37 centimeters. So, so that's what we're finding. We're finding the distance around circles. Our last one, if our radius is 4, our diameter is 8, so our circumference is 8 pi. So we'd go to your calculator and just type in 8 pi. So 25.13. All right. Hopefully people are understanding this so far. If a circle has a radius of 20 pi, so we know the circumference is 2 pi r. That's our equation if we want to find the radius. And now we know the circumference is 20 pi, so let's just fill that in for the c. All right, now if 20 pi equals 2 pi r, we can divide both sides by 2 pi. Now 2 pi divided by 2 pi is 1, so that cancels out. Pi divided by pi is 1, so that cancels out. So 20 over 2 is 10. So my radius is going to be 10. If the circumference of the circle is 7 pi equals 2 pi r. Divide by 2 pi, and r will just be 3.5. Another way you can look at this is that represents the diameter, so then the radius is just half of that. Now in this situation, the circumference of the circle is 50. It is not 50 pi, it is just 50. So we'll write 50 is equal to 2 pi r. First thing we can do is divide by 2, so 25 equals pi times r. Next thing you divide by pi, so we can do 25. Once my thing starts working, 25 divided by pi, and we get the answer 7.96. Now, we could have just started off and divided both sides by 2 pi, but there's a very common mistake that people make when they do this. I'll show you. Now in this situation, if I do 50 divided by 2 pi, I don't get the answer I want. I don't get 7.9, I get 78. What I should have written in here is parentheses around my 2 pi. Because what this previous one does is 50 divided by 2 and multiplies that answer by pi. But we want that pi to be in the denominator. So in order to do that correctly, we have to put parentheses, and notice how we get the same answer. All right. Now things get a little bit more complicated with arc length. Now we want to find the arc length, which is just the distance from A all the way to B. Now it shows us that this degree measure is 100. So 100 out of the whole circle would be 360. So our part is 100 out of the whole thing, which is 360. We can set up a proportion, which would be the arc length divided by the distance around the whole circle, which would be, if the radius is 2, the diameter is 4, so the circumference will be 4 pi. So I got this because the circumference is 4 pi. So now we just cross multiply and divide. 4 pi times 100 is 400 pi. 360 times x is 360x. And then we divide both sides by 360. And we could just take 400 divided by 360, so it would be 1.1 repeating pi. And that is the arc length from A to B. Now if we want to find the arc length of ACB, this is a major arc. So we start at A, we pass C, and we get all the way to B. Well, if this is 70 degrees, we have to find this angle on the outside, which if we take 360 minus 70, we'll get 290. So we need to set up this proportion. We want 290 3/60ths of the circle, and we're looking for the part of the entire circumference, which is, if this is 6, the diameter is 12, so the circumference is 12 pi. So now we cross multiply and divide. 360 times x is 360x. 12 times 290 is 3480. So this would be 3480 pi. Now I have to divide 360 on both sides. So we'd have 3480 pi over 360. So when we do this, our correct answer will be 9.6 repeating pi. So that's the distance in red on the arc of the circle. That's the length of that arc. Now the question asks, the measure of the angle of the arc is 110 degrees. So that we know this is 110. The arc length, so this distance is 12 centimeters. Now we want to find the radius. So we set up the equation the same way, 110 out of 360. Now it's going to be the arc length over the circumference. The formula for circumference is 2 pi r. Now we cross multiply. 110 times 2 is 220 pi r. 12 times 360 is 4,320. So now in order to solve this, we have to divide by 220 pi. So let's see if we can do this on our calculator. Remember, if we're going to divide by 220 pi, we do need parentheses. And that becomes 6.25. So now our r is 6.25. So that's the distance. That's the radius of the circle. All right. Let's try this next one. Now, if you were doing this at home, I would pause the video and see if you can do this one on your own, because it's similar to the previous one. The measure of the angle is 30 degrees. The arc length is 20 centimeters. We want to find the radius. So 30 out of 360 is going to equal the arc length over the entire circumference. Now when we cross multiply, this is going to be 7,200 equals 60 pi r. So now we just take 7,200 divided by 60 pi. 38.2. That is my radius. All right. Now there's two more questions left here in today's lesson, and they both have to do with clocks. Now, if we want to find the angle that is formed on a clock when it's 3:25, first I need to know how to count. Now I get it. So 3:25, 25 would be down here at the 5, and when it's 3:25, it's going to be somewhere between the 3 and the 4. All right, we know an entire circle is made up of 360 degrees. So if we divide those into 12 units, 360 divided by 12, that means between each of these, that will be 30 degrees. So we know this is 30 degrees, but we don't know how many degrees is located here. So what we would like to do is we want to find out how far that hour hand moves by the time 25 minutes have passed. Well, we know that's 25 minutes in an hour, so 25 out of 6, 25 60ths of the way between here, and there's 30 degrees in this section, so we're 25 60ths of 30 degrees. So if we cross multiply and divide here, we'd have 6, if I put an x, 60 times x, this would be 750. Now divide by 60, and we would get 12.5. So that's saying we're 12.5 degrees past the 3, and since this is 30 degrees, that means there's 17.5 degrees down here. So if I want to find this total degree measure, 30 plus 17.5 would be 47.5 degrees between the hands at 3:25. Now if you're at home, I would try this one on your own and see how it goes. At 11:40, so 11:40, 40 is going to be down here. 11 will be up there. So we're looking for the smallest angle. We're not looking for this angle out here. We're just looking for the smallest angle between these hands. So we know that it's still going to be 30 degrees from there to there, 30 here, and 30 degrees here. So we know that it's more than 90 degrees. So to find out how far between the 11 and the 12 the hour hand has gone, we know we've gone 40/60ths of the way, and we know that that's out of 30 degrees. Now last time I cross multiplied and divided, that's a totally reasonable way to do this, but another way we can do this is how can I reduce this fraction so it has a 30 on the bottom? Well, we divide by 2. So if we divide by 2 in our numerator, that x would be, not 30, but 20. So that would be 20 degrees that's located here. So since this is just 20 degrees, now we have 30 plus 30 plus 30 plus 20. So that's 110 degrees that are between the hands of a clock at 11:40. All right, hopefully that's helped you, and it'll help you get through the rest of the assignment, 4 through 9. Good luck.